In this video, we are going to discuss about second order homogeneous recurrence relation. Totally, we are going to solve 4 examples in this video. Here the roots may be either real and distinct and real and equal and imaginary roots. So totally we have 3 cases are there. Case 1 means roots are real and different. Case 2 means roots are real and equal. Case 3 means roots are imaginary. On case 1, we are going to solve 2 examples. And then on case 2 and case 3, we are going to solve 1 example. Okay. So after knowing all these, after understanding all these 4 problems, you can solve any problem which is given on second order homogeneous recurrence relation in the examination. Let us solve the first example. Solve the following recurrence relation: an plus an minus 1 minus 6an minus 2 is equal to 0 for all n greater than or equal to 2. Second order homogeneous recurrence relation means n value should be greater than or equal to 2. If it is third order recurrence relation, then n value should be greater than or equal to 3. If it is first order recurrence relation, then n value should be greater than or equal to 1. Okay. Here second order means we must have 3 terms in the corresponding recurrence relation, such as an minus 1, an minus 2. So by observing these 3 terms, we can conclude that this recurrence relation is in second order homogeneous form. Let us see what is the second order homogeneous recurrence relation. Solution: the second order homogeneous recurrence relation is second order homogeneous recurrence relation is Cn into an plus Cn minus 1 into an minus 1 plus Cn minus 2 into an minus 2 is equal to 0. So if we compare this equation, this second order homogeneous recurrence relation with the given problem, we can get what is Cn value: Cn minus 1, Cn minus 2. Here Cn minus 1, Cn minus 2 are nothing but constant coefficients. Okay. On comparison, what is Cn value? 1 into, this can be written as an, can be written as 1 into an. So Cn is equal to 1. Next, an minus 1 can be written as 1 into an minus 1. So Cn minus 1 is equal to 1. Next, Cn minus 2 into an minus 2. So here Cn minus 2 is nothing but minus 6. Cn minus 2 means minus 6. Next, Cn minus 3 is equal to, this is second order only. So there is no Cn minus 3. So Cn is equal to 1. Cn minus 1 is equal to 1. Next to Cn minus 2 is equal to minus 6. Now let us see what is the auxiliary equation. Auxiliary equation can also be called as a characteristic equation also. Auxiliary equation or characteristic equation is, let us note down the formula: Cn into k square plus Cn minus 1 into k plus Cn minus 2 is equal to 0. We know what is Cn minus 1 and what is Cn minus 2. Let us substitute the values. What is Cn? 1. So 1 into k square plus what is Cn minus 1? 1. 1 into k plus what is Cn minus 2? Minus 6. Minus 6 is equal to 0. So 1 into k square means k square plus 1 into k means k plus into minus means minus minus 6 is equal to 0. Directly from the recurrence relation also we can write the auxiliary equation or characteristic equation. An means what? K square plus an minus 1 means k minus 6 is equal to 0. An minus 2 is equal to, it is nothing but a constant. Okay. So k square plus k minus 6 is equal to 0. Directly by observing the recurrence relation also we can write the auxiliary equation, but it is better to write all these statements. Now let us find out the roots. So what are the roots here? If we perform add, then we have to get k. If we perform multiplication, we need to get 6k square. So k square plus 3k minus 2k minus 6 is equal to 0. 3k minus 2k means k. If we perform multiplication, plus into minus means minus 6k square. So we can common k. So k plus 3 minus we can common 2 into k minus 3 is equal to 0. Okay. So here minus 2 k plus 3 minus 2 of k plus 3 is equal to 0. Okay. So here k minus k plus 3 into k minus 2 is equal to 0. So what are the roots here? What are the roots here? K is equal to minus 3 and k is equal to 2. So k is equal to minus 3 and what is the second root? K is equal to plus 2. Okay. So we can write this as k1, this as k2. Here the roots are real and different. Real means some floating point values. Minus 3 can be written as minus 3.0. 2 can be written as 2.0. So those roots are real and distinct, different. Minus 3 is one root, 2 is another root. Distinct, different. Thus the general solution for second order homogeneous recurrence relation is. So here we have to follow case 1. Why? Because roots are real and different. If roots are different, then we need to follow case 1. Here the formula here is an is equal to a into what is the first root? K1 power n plus b into K2 power n. So this is the general solution when the roots are different. So this can be written as a into what is K1 value? K1 value is minus 3. So minus 3 power n plus b into what is K2 value? K2 value is 2 power n. So minus 3 plus 2. Okay. Power n. Let it be equation 1. Okay. Let it be equation 1. Okay. Now we have to find out what is a value, what is b value. For that initially two conditions are given. A0 is equal to minus 1, A1 is equal to 8. Initially assumes that n is equal to 0 and derive the equation and assume and substitute 1 in place of n and derive the new equation. From that we can get a and b value. If you find a and b value, then substitute a and b here, then it will become the general solution. Okay, very, very simple. Let us erase this portion. Let us erase this portion. So what is the initial conditions? Initial conditions. So totally two values are given. A0 is equal to minus 1, A1 is equal to 8. A0 is equal to minus 1, A1 is equal to 8. Substituting n is equal to 0 in equation 1. So this is equation 1. So we can get an is equal to, in place of n we have to substitute 0. A0 is equal to a into minus 3 power, what is n value? 0 plus b into 2 power, what is n value? 0. Already a0 is given as minus 1. So minus 1 is equal to a into anything power 0 is equal to 1. Why? Because we have a formula called a power 0 is equal to 1 plus b into anything power 0 is equal to 1. So we can write as minus 1 is equal to a into 1a plus b into 1b. So we can write as a plus b is equal to minus 1. So this is the first equation. Likewise substitute n is equal to, what is the next value? 1. Substituting n is equal to 1 in equation 1. Then we will get a1 is equal to a into minus 3 power 1 plus b into 2 power 1 plus b into 2 power 1. What is a1 value? 8. So 8 is equal to a into minus 3 means minus 3a plus why? Because minus 3 power 1 is equal to minus 3 plus b into 2 power 1 is equal to 2. So that is equal to 2b. So we can write this equation as minus 3a plus 2b is equal to 8. Minus 3a plus 2b is equal to 8. Now from these two equations we have to get a and b value. Okay, we have to get a and b value. What is the first equation? A plus b is equal to minus 1. What is the second equation? Minus 3a plus 2b is equal to 8. Minus 3a plus 2b is equal to 8. Okay. Yeah, we can multiply this equation with 2. Then we will get 2a plus 2b is equal to minus 2. Next, minus 3a plus 2b is equal to 8. Let us write the next equation as it is. So here we have minus, so plus, here we have plus, minus, here we have plus, minus. So 2a plus 3a means 5a. We can cancel 2b and minus 2b is equal to minus 2 minus 8 means minus 10. So 5a is equal to minus 10. So we can get a as minus 2. Next we need to get b value. We know that a plus b is equal to minus 1. We know that a plus b is equal to minus 1. So from this we can get b value. B is equal to minus 1 minus a. Minus 1 minus a, minus 1 minus into minus 2 is equal to plus 2. Minus of minus means plus. So minus 1 plus 2 means 1. So we got a as 1, we got b as 1 and a as minus 2. Now the general solution is we need to substitute a value and b value in this equation. So general solution for this problem is an is equal to, what is a value? Minus 2 into minus 3 power n, minus 3 power n plus, what is b value? B value is 1. So 1 into 2 power n. So this is the general solution for this problem. Now let us see the second example. Example 2. Solve the following recurrence relation. The second example is also based on case 1. So what is case 1? Case 1 means roots are real and distinct. If roots are real and distinct, then the formula is a into k1 power n plus b into k2 power n. Now let us solve the second example based on case 1 only. Based on case 1 only. So here the problem is like this: a n plus 2 minus 3 into a n plus 1 plus 2an is equal to 0 for all n is greater than or equal to 0, given that a naught is equal to 1, a1 is equal to 6. an plus 2 minus 3an plus 1 plus 2an is equal to 0 for all n is greater than or equal to 0, given that a naught is equal to 1 and a1 is equal to 6. Here n is greater than or equal to 0, but second order homogeneous recurrence relation means n value should be greater than or equal to 2. So now what we have to do? In place of n, we need to substitute n minus 2. So n minus 2 greater than or equal to 0. Then we can write as n is greater than or equal to 2. Okay. So in order to get second order homogeneous recurrence relation, what we have to do is substitute n minus 2 in place of n. In place of n, let us substitute n minus 2. So a in place of n, substitute n minus 2. n minus 2 plus 2 minus 3 into a. In place of n, substitute n minus 2. n minus 2 plus 1 plus 2 into a. In place of n, substitute n minus 2 is equal to 0 for all n minus 2 is greater than or equal to 0. So this can be written as n minus 2 plus 2 means n minus 3 into a. This can be written as n minus 2 plus 1 means n minus 1 plus 2 into a n minus 2 is equal to 0. an minus 3 an minus 1 plus 2 into an minus 2 is equal to 0 for all. So we can shift this minus 2 towards the right side, then n greater than or equal to 2. So this is the second order homogeneous recurrence relation. We know the second order homogeneous recurrence relation. The second order homogeneous recurrence relation is Cn an plus Cn minus 1 into an minus 1 plus Cn minus 2 into an minus 2 is equal to 0. After comparison, we will get Cn is equal to 1, Cn minus 1 is equal to minus 3, Cn minus 2 is equal to 2. Cn is equal to 1, Cn minus 1 is equal to minus 3, Cn minus 2 is equal to 2. We know the auxiliary equation. Auxiliary equation or characteristic equation is, for theory, let us follow the first problem. The theory is same only for all the problems. Okay. Auxiliary equation or characteristic equation is Cn into k square plus Cn minus 1 into k plus Cn minus 2 is equal to 0. What is Cn? 1. So 1 into k square means k square. Cn minus 1 means minus 3. So minus 3k plus Cn minus 2 is 2 is equal to 0. So this can be written as k square minus 2k minus k plus 2 is equal to 0. So we can common k. So k into k minus 2 minus 1 k minus 2 is equal to 0. So what is k? What is k value? K minus 1 into k minus 2 is equal to 0. So we can get k is equal to 1 comma 2. So k1 is equal to 1. Next to k2 is equal to 2. K1 is equal to 1 and k2 is equal to 2. So here also the roots are real and different. Roots are real and different. So real and different means the solution is case 1. What is the solution in case 1? What is the solution? General solution of the case 1 is, already we saw the first problem. An is equal to a into k1 power n plus b into k2 power n. So that is equal to a into what is k1? 1 power n plus b into what is k2? 2 power n. Okay. Now we need to find out a and b. In order to find out a and b, we have to use the initial conditions. So what are the initial conditions that are given? Initial conditions are a0 is equal to 1, a1 is equal to 0. So we have to substitute n is equal to 0 first. Substitute n is equal to 0 in equation 1. This is equation 1. An is equal to. Substitute n is equal to 0 in equation 1. So we can get a0 is equal to a into 1 power. In place of n we are substituting 0 plus b into 2 power 0 plus b into 2 power 0. So a0 is equal to a into anything power 0 is equal to 1. A into 1 means a plus b into anything power 0 is equal to 1. So plus b. What is a0 value? Already we know about a0 value. What is a0 value? 1. So 1 is equal to a plus b. So this can be written as a plus b is equal to 1. Now let us substitute the second one. Substitute n is equal to 1 in equation. Substitute n is equal to 1 in equation 1. Then we will get, in place of n we have to substitute 1. a1 is equal to a into 1 power. In place of n we have to substitute 1. We have to substitute 1. A into 1 power 1 plus b into 1 power 1. So that is equal to, so 1 power 0 means what? 1 only, a plus b. So here also 1 power 1 means 1. So a into 1 means 1 plus b into 1 power 1 means 1. So what is a1 value? We know about a1 value. So 6 is equal to a plus b. So a plus b is equal to 6. So here we have what is here? I'm sorry, here there is a small mistake. Here what is k2 value? K2 value is 2, not 1. So 2 power 1, 2 power 1. So 2 power 1 means 2b. So this is 2b. So we can say that a plus 2b is equal to 6. Now from this equation and this equation, we have to get a and b. So what is the first equation? A plus b is equal to 1. Second equation, a plus 2b is equal to 6. So subtraction, minus minus minus, a minus a, we can cancel them. B minus 2b means minus b is equal to 1 minus 6 means minus 5. So we can say that b is equal to 5. B is equal to 5. We know about the first equation. What is the first equation? A plus b is equal to 1. So a is equal to 1 minus b. 1 minus what is b value? 5. So 1 minus 5 means what? Minus 4. So a value is minus 4 and what is b value? B value is plus 5. Now we have to substitute these two values in our equation. What is our equation? This equation. So substitute those values. An is equal to minus 4 into minus k1 power 1 power n plus what is b value? B value is 5. So 5 into 2 power n. So this is the general solution for this recurrence relation. Now let us solve the next example. The next example is based on case 2. Here case 2 means the roots are real and equal. The roots are real and equal. Case 2 means roots are real and equal. We are going to solve one example on case 2. Next we are going to solve one more example on case 3. Okay. Let us see case 2. Solve the recurrence relation an minus 6 into an minus 1 plus 9 into an minus 2 is equal to 0 for all n is greater than or equal to 2, given that a0 is equal to 5 and a1 is equal to 12. An minus 6an minus 1 plus 9an minus 2 is equal to 0 for all n is greater than or equal to 2, given that a0 is equal to 5, a1 is equal to 12. Okay. Here this is already in second order homogeneous recurrence relation. Already we have seen the first two examples. Let us write the auxiliary equation or characteristic equation directly. An means we can write as k square. 6an minus 1 means we can write as 6k plus 9an minus 2 means we can write as 9. K square minus 6k is equal to 0. So k square minus 3k plus 9 is equal to 0. So k into minus 3, k into minus 3 is equal to 0. So what are the values? K minus 3 into k minus 3 is equal to 0. So the roots are k is equal to 3. So we can say that the roots are real and equal. The roots are equal. If the roots are equal, then we have to follow case 2. In case 2, the general solution is an is equal to a plus bn into k power n. This is the formula. We have to use this formula. An is equal to, we can write as a plus bn into, here k means k1 and k2 are same only. What is k value? 3. So 3 power n. So this is equation 1. Now we have to substitute the 0 value, 1 value in place of n in order to obtain a and b, and then we need to substitute those values. So substitute n is equal to 0 in equation 1. Then we get a0 is equal to a plus b into what is n value? 0 into 3 power n. 3 power what is n value? 0. What is a0 value? 5. 5 is equal to a plus b into 0 means a plus 0, that is a. 3 power 0 is equal to anything power 0 is equal to 1. So directly we got a as 5. Now let us substitute b value. Substitute n is equal to 1 in equation 1. Then we will get a1 is equal to a plus b into what is n value? 1 into 3 power 1. 3 power what is n value? 1. What is a1? a1 is already given. 12 is equal to a plus b into 3. So we can write as a plus b is equal to 12 by 3. 12 by 3 means 4. Already we know about a. What is a? 5. So b is equal to 4 minus a. 4 minus 5. 4 minus 5 means 1. Now we know A value, B value. Let us substitute those values in this equation. So the general solution for this recurrence relation is an is equal to a plus bn. A means 5 plus bn. So plus into minus means minus. What is b value? 1. So 1 into n means n, 3 power n. So this is the general solution for this problem. So it will comes under case 2. Okay. In the examination, problem will be given. So based on the problem, we have to solve the problem. Okay. Let us solve the last example. The last example is based on case 3. Case 3 means the roots are real and distinct. Case 3 means roots are real and distinct. Let us solve the last example. An is equal to 2 into an minus 1 minus an minus 2 for all n is greater than or equal to 2, and the initial conditions are a0 is equal to 1, a1 is equal to 2. An is equal to 2 into an minus 1 minus an minus 2 for all n is greater than or equal to 2. So this is already in the second order homogeneous form, recurrence relation form. A0 is equal to 1, a1 is equal to 2. Okay. So let us translate this one into second order. An is equal to 2 into a minus 1 means 2 into an minus 1 minus 2 into an minus 2. So let us move these two terms to the left side. An minus 2 into an minus 1 plus 2 into an minus 2 is equal to 0. An minus 2 into an minus 1 plus 2 into an minus 2 is equal to 0. Directly we can get the characteristic equation. So k square minus 2k plus 2 is equal to 0. Here the roots are imaginary. So we know the formula. D is equal to minus b. It is not possible to find out any root here. D is equal to minus b plus or minus square root of b square minus 4ac by 2a. So D is equal to minus b. Here b value is, here a value is 1, b is equal to minus 2, c is equal to 2. Minus b, minus of minus means plus, 2 plus or minus, square root of b square means 2 square 4, 4ac means 4 into 1 into 2, 8 by 2 into a means 2. So this can be written as, 2 plus or minus square root of 4 minus 8. 4 minus 8 means minus 4. Minus 4 can be written as 4 into I square. Why? Because I square means minus 1 by 2. So this can be written as 2 plus or minus 2 by 2 means 1. So 1 plus or minus square root of so let us see this one. So 2 plus or minus square root of 4 into I square means what? 2 into I by 2. So this can be written as 2 by 2. 1 plus or minus 2 into I by 2 means I. 2I by 2 means what? 2 cancel I. So here the roots are 1 plus I, 1 minus I. So K1 is equal to 1 plus I. K2 is equal to 1 minus I. K2 is equal to 1 minus I. Here the this is in the form of P plus IQ. So this is also in the form of P minus IQ. Here the two roots are in the form P plus IQ and P minus IQ. So from this we will get P is equal to 1, Q is equal to 1. Okay. So we can say that here the roots are imaginary. So the general solution is we have to follow case 3. In case 3 the formula is an is equal to r power n into a cos n theta plus b sin n theta. We have to follow this formula, and the formula for r is equal to square root of p square plus q square, and theta is equal to tan inverse of q by p. So by following these formulas we need to get the solution. So for space constraints I am erasing this portion. Let us solve the problem now. First let us find out r. R is equal to square root of p square plus q square. P value is 1, q value is 1. Square root of 1 square plus 1 square. 1 square means 1. So 1 plus 1 means 2. So r is equal to root 2. Next to theta is equal to, what is the formula? Tan inverse of q by p. Q value is 1, P value is 1. Tan inverse of 1 by 1 means tan inverse of 1. Tan inverse of 1 means 45 degrees. Tan 45 degrees means 1. So tan inverse of 1 means 45 degrees. Okay. Now let us substitute all these values in AN. AN is equal to, what is R? We got R as root 2. So root 2 power n. Next A cos n theta. We need to find out A value. A cos n. What is theta? We got theta as 45 degrees. Plus B sin n. What is theta value? 45 degrees. Here this is the general solution. Let this equation is 1. Now we have to substitute the initial conditions in these two equations in order to obtain A and B values. Okay. Substitute n is equal to 0. Substitute n is equal to 0 in equation 1. Okay. Now an means a0 is equal to root 2 power 0 into a cos, what is n value? 0 into 45 degrees plus b sin 0 into 45 degrees. What is a0 value? 1. 1 is equal to, anything power 0 is equal to 1 into a cos 0 into 45 means 0 plus b sin 0 into 45 means 0. Now let us see, 1 is equal to 1 into a into, what is the formula for cos 0? So what is the formula for cos 0? Cos 0 means 1 plus b into sin 0 means 0. So 1 is equal to 1 into a into 1 means a. So therefore a is equal to b. A is equal to 1. Now we have to obtain b. In order to obtain b, let us write here. Substitute n is equal to 1 in equation 1. In equation 1. N is equal to 1. So a1 is equal to root 2 power 1 into a cos n. A cos, here what is n? N means 1. So 1 into 45 degrees plus b sin 1 into 45 degrees. 1 into 45 degrees. What is a1 value? 2. 2 is equal to root 2 power 1. A cos 1 into 45 means cos 45. The value of cos 45 is 1 by root 2 plus b into sin 1 into 45 degrees means sin 45. The value of sin 45 is 1 by root 2. Okay. So we can write as 2 is equal to root 2 into, so root 2 a plus b. We can cancel root 2. So the equation is a plus b is equal to 2. A plus b is equal to 2. A plus b is equal to 2. Already we know about a. A is equal to 1. So b is equal to 2 minus what is a? 1. So b is equal to 1. So a value is 1 as well as b value is also 1. So now we have to substitute a and b in the relation. So the general solution for the problem is an is equal to root 2 power n. A, what is a value? 1. 1 cos n 45 degrees plus what is b value? 1. 1 sin 45 degrees. So this is the general solution for this problem. So in this way we can solve any problem based on the second order homogeneous recurrence relation.